Have you ever looked up at the night sky and felt small? Billions of stars, vast distances, a universe of mysteries. Now imagine holding a grain of sand in your hand. It seems insignificant, right? Yet, within that tiny speck, reside the fundamental building blocks of everything around us, atoms and molecules. Understanding atoms and molecules is like unlocking a secret code. This code unveils the mysteries of the universe, from the smallest grain of sand to the largest star. It explains why water is wet, why fire burns, and how your body functions. So, join me on a journey into the fascinating world of atoms and molecules. We'll explore their properties, their interactions, and their profound impact on our everyday lives. Get ready to see the world in a whole new light. Atoms are the tiny building blocks of matter. Imagine the smallest thing you can possibly think of. An atom is even smaller than that. They are so small that millions of them could fit on the period at the end of this sentence. Despite their size, atoms are incredibly important. They are the basic units that make up everything around us, from the air we breathe to the water we drink. Atoms are like the letters of the alphabet. Just like letters combine to form words, atoms combine to form everything we see and interact with. Atoms themselves are made up of even smaller particles: protons, neutrons, and electrons. Protons and neutrons hang out together in the nucleus, the atom's center. Electrons, much smaller and lighter, whiz around the nucleus like planets orbiting a star. Protons have a positive electrical charge, while electrons have a negative charge. Neutrons, as their name suggests, have no charge. They are neutral. The number of protons in an atom determines what element it is. For example, all oxygen atoms have 8 protons. Atoms are sociable. They like to combine with other atoms. When 2 or more atoms join together, they form a molecule. Molecules are like the words in our language. They are formed by combining atoms in specific ways. A simple example is the water molecule. It's made of 2 hydrogen atoms and 1 oxygen atom, H2O. The way these atoms bond gives water its unique properties, like its ability to dissolve many substances and its high boiling point. Section 5, Chemical bonds, the glue that holds it all together. But what holds these atoms together in a molecule? The answer is chemical bonds. These bonds are like tiny forces of attraction between atoms. They occur because atoms want to have a stable number of electrons in their outer shell. There are different types of chemical bonds, but the most common are covalent bonds and ionic bonds. In covalent bonds, atoms share electrons. In ionic bonds, one atom donates an electron to another, creating oppositely charged ions that attract each other. Section 6, Water, a molecule of life. Let's revisit our friend, the water molecule H2O, to understand how its structure dictates its function. Water is essential for life as we know it. Its unique properties stem from its bent shape and the way its atoms share electrons. The oxygen atom in a water molecule attracts electrons more strongly than the hydrogen atoms. This makes water a polar molecule with a slightly negative end, oxygen, and a slightly positive end, hydrogen. This polarity allows water molecules to form weak bonds with each other and with other polar molecules, giving it its remarkable solvent properties. Section 7. Everyday molecules, from soap to smartphones. Molecules are everywhere. The air we breathe is a mixture of molecules, mainly nitrogen, N2, and oxygen, O2. The food we eat is made of complex molecules like carbohydrates, proteins, and fats. Think about the things you use every day. Soap cleans by using molecules that attract both water and grease. Plastics are made of long chains of molecules called polymers. The screen of your smartphone relies on the properties of liquid crystals, a special type of molecule. Section 8. Atoms and molecules in action, from cooking to breathing. Atoms and molecules are not static entities. They are constantly in motion, interacting with each other. These interactions are the basis of all chemical reactions, from the rusting of iron to the digestion of food in our bodies. When we cook, we are using heat to speed up chemical reactions, breaking down some molecules and forming new ones. When we breathe, oxygen molecules from the air enter our lungs and bind to hemoglobin in our red blood cells, which then transports oxygen throughout our bodies. Section 9. Conclusion, the building blocks of our world. Atoms and molecules are the fundamental building blocks of the universe. Understanding these tiny particles unlocks a deeper understanding of the world around us, from the simplest everyday phenomena to the most complex scientific processes. So, the next time you look at a grain of sand, remember the incredible world hidden within. It's a world of atoms and molecules constantly interacting and shaping the universe we know and love. And who knows what other secrets these tiny particles hold, waiting to be discovered.